Hello, greetings. My name is Yash Tripathi, roll number 1143, and today, under AIL Art Integrated Learning subject Chemistry, I am going to explain about concepts of oxidation and reduction. My team members are Anant Sharma, Vishnu Jaybhaye, Srushti Patil, and Ekeshwar Sinha. So let's begin. So, oxidation can be defined as loss of electron or gain of oxygen or removal of hydrogen, while the term reduction indicates the gain of electron or gain of hydrogen or removal of oxygen. According to classical concept, oxidation is an addition of oxygen or electronegative radical slash element, removal of hydrogen or electropositive radical slash element. According to the classic concept, the reduction is an addition of hydrogen or electropositive radical slash element and removal of oxygen or electronegative radical slash element. In simple words, oxidation can be defined as the gain of oxygen and reduction can be termed as a loss of oxygen. The agent that oxidizes an element or a compound is known as oxidizing agent, while the agent which reduces a compound or element is known as the reducing agent.
Hello, I'm Srushti Patil of class 11th. So here are the examples of oxidation and reduction. A classic example of oxidation is when iron combines with oxygen to form iron oxide or rust. The iron is said to have oxidized into rust. The chemical reaction is 2Fe plus O2 that gives Fe2O3. Another examples of oxidation where an element combines with oxygen is the reaction between magnesium metal and oxygen to form magnesium oxide. Many metals oxidize, so it's useful to recognize the form of equation, that is 2Mg plus O2 that gives 2MgO. Simple example of reduction reaction between copper oxide and magnesium is Al2 copper and magnesium oxide, that is CuO plus Mg that gives Cu plus MgO. Reaction that extract iron from iron ore is also known as example of reduction. Fe2CO3 plus 3CO that gives 2Fe plus 3CO2. The iron oxide undergoes reduction, loses oxygen to form iron, while the carbon monoxide is oxidized, gains oxygen to form carbon dioxide. In this context, iron oxide is the oxidizing agent which gives oxygen to another molecule. Carbon monoxide is reducing agent which removes oxygen from a chemical species.
I am Ekeshwar Sinha from class 11. My roll number is 3112 and my topic is oxidizing and reducing agents. The substance, atom, ion and molecule that gain electron and is thereby reduced to a low valency state is called oxidizing agent. Substance that loses electron and is thereby oxidized to a higher valency state is called a reducing agent. An oxidizing agent, molecules made up of electronegativity elements, example O2, O3 and X3 halogens. Compounds containing an element which is in the higher oxidized state, example KMNO4, K2CV207, HNO3 and KClO3. Oxides of metal and non-metals, example MgO, CuO, CrO3, P4010. Fluorine is the strongest oxidizing agent. Important reducing agent. All metals, example Na, Zn, Fe, Al. A few non-metal examples C, hydrogen, S and P. Hydroxides, example HCl, HBr, HL, H2S. Few compounds containing an element in lower oxidation state, example FeCl2, FeSO4, SnCl2, Hg2Cl2. Metallic hydrides, example NaH, LiH, CaH2, etc. Organic compounds like SCOOH.
My name is Anant Sharma and I am studying in class 11th. My roll number is 1103. My art integrated learning in chemistry topic is types of redox reactions. Combination reactions combine elements to form a chemical compound. As usual, oxidation and reduction occur together. Example is formation of water. Equation 2H2 plus O2 gives 2H2O. The sum of oxidation states in the reactants is equal to that in the products. In this equation, both H2 and O2 are the molecular forms of their respective elements and therefore their oxidation states are 0. The product is H2O. The oxidation state is -2 for oxygen and +1 for hydrogen. Decomposition reactions are the reverse of combination reactions, meaning they are the breakdown of a chemical compound into its component elements. Example, equation 2H2O gives 2H2 plus O2. In this equation, the water is decomposed into hydrogen and oxygen, both of which are neutral. Similar to the previous example, H2O has a total oxidation state of 0, with which H taking on a +1 state and oxygen of -2. Thus, decomposition oxidizes oxygen from -2 to 0 and reduces hydrogen from +1 to 0. Displacement reactions, also known as replacement reactions, involve compounds and the replacing of elements. They occur as single and double replacement reactions. A single replacement reaction replaces an element in the reactants with another element in the product. Example, equation Cl2 plus 2 NaBr gives 2 NaCl plus Br2. Calculation is given here. In this equation, Cl is reduced and replaces Br while Br is oxidized. A double replacement reaction is similar to the single replacement reaction but involves replacing two elements in the reactants with 2 in the product. Example, equation Fe2O3 plus 6HCl gives 2 FeCl3 plus 3H2O. In this equation, Fe and H as well as O and Cl trade places. Combustion reactions always involve oxygen and an organic fuel. Combustion reaction of methane is an example of a combustion reaction. Disproportionation. In some redox reactions, substances can be both oxidized and reduced. These are known as disproportionation reactions. One real-life example of such a process is the reaction of hydrogen peroxide H2O2 when it is poured over a wound. At first, this might look like a simple decomposition reaction because hydrogen peroxide breaks down to produce oxygen and water. 2H2O2 aqueous gives 2H2O liquid plus O2 gas. The key to this reaction lies in the oxidation states of oxygen. However, notice that oxygen is present in the reactant and both of products. In H2O2, oxygen has an oxidation state of -1. In H2O, its oxidation state is -2. And it has been reduced in O2, however, its oxidation state is 0 and it has been oxidized. Oxygen has been both oxidized and reduced in the reaction, making this a disproportionation reaction. Thank you.
Hello everybody, my name is Vishnu and in this part I am going to tell you about oxidation number. Oxidation number, also called oxidation state, the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. Let's now know some more about oxidation number. Each atom that participates in an oxidation reduction reaction is assigned an oxidation number that reflects its ability to acquire, donate, or share electrons. The iron, for example, has an oxidational number of +3 because it can acquire 3 electrons to form a chemical bond, while the oxygen ion has an oxidation number of -2 because it can donate 2 electrons in an electronically neutral substance. The sum of the oxidation numbers is 0. For example, in hemite, the oxidation number of the 2 iron atoms balances the oxidation number of the 3 oxygen atoms. Certain elements assume the same oxidation number in different compounds. Fluorine, for example, has the oxidation number of -1 in all its compounds. Others, notably the nonmetals and the transition elements, can assume a variety of oxidation numbers. For example, nitrogen can have any oxidation number between -3 in ammonia. In the nomenclature of inorganic chemistry, the oxidation number of an element that may exist in more than one oxidation state is indicated by a Roman numeral in parentheses after the name of the element. Example: iron 2 chloride FeCl2, iron 3 chloride FeCl3. Thank you.